Hi friends, and welcome to this another session. It's based on mathematics with mechanics. This question was proposed to me by a student as well, and the question says that a body of mass is placed on an inclined plane, and the body is at the point of slipping. That is, slipping means the body is at the point of rolling down this inclined plane, and they've given us the angle to be 30 degrees. And since the body is at the point of slipping, they want us now to get the coefficient of static friction, that is mu s. Yes, it has a symbol mu s. They want us to get that value. Now, I want to give a remark on this question. We know that mu s, we cannot get the exact value of mu s because, okay, now let me just give the differences between the coefficient of static friction and that of kinetic friction. When a body is at rest, right? When the body is at rest and the body is at a point of sleeping, the body is still at rest normally. What permits the body to keep being at rest and not be in motion is the coefficient of static friction, okay? Because just take for instance that a bench is on the floor, right? And you want to pull that bench. The bench will continue to be on the floor until the force in which you are pulling the bench is able to overcome that coefficient of static friction, okay? A body which possesses the coefficient of kinetic friction is a body which is already in motion. Yes, a body which is already in motion possesses the coefficient of kinetic friction, while a body rest possesses the coefficient of static friction. The coefficient of static friction is not a force. It's not a force. It's just a unitless value. Okay. Yes, it's not a force. So let's see. If this body is at the point of sleeping, that therefore means if I decide to resolve this force now, if I decide to resolve this force, I can bring forth a perpendicular arrow here, and I can just assume that the body has a mass m. Yes, let me just say the body has a mass m. If it has a mass m, that therefore means that it has a weight of mg, where g is the gravitational field strength or the acceleration due to gravity. Then the component this way must be mg cos theta. Then the component which is parallel to the plane has the value mg sine theta. This is the component of the weight which is so particular that this particle should slip. Okay. Yes. Then if the particle is at the point of slipping, that means that the frictional force should be in this direction, right? We can call that Fs. That's the frictional force. Then we know that on the same line of action, on the same line, we have the normal reaction force. Let's just call that N. You have the normal reaction force. So this is a free body diagram that you're supposed to adopt. So in this case, if the particle is at the point of sleeping, the particle has not slept yet. I also want to let you know that the coefficient of friction force, let's call it that Fs, is always less than or equal to mu s times n. Yes, it's always less than this value. It's always less than or equal to that value. So if we want to calculate the coefficient of static friction, we know that it is always less than or equal to mu s times n. I can take a case where it's equal to it. Therefore, I'm now going to have my friction force Fs, which is equal to, I'll resolve these forces, which in this case is equal to my mg sine theta. But my theta is 30 degrees, right? Good. But this Fs is just what? My mu s. In the case where they are both equal, I'll just say my mu s times the normal reaction force n is equal to what? My mg sine 30, since the theta is 30 degrees. Then that therefore implies my mu s is going to be mg sine 30 degrees. All that divided by n. Wait, all that divided by n. But I know that my n, according to this my free body diagram, it is just what? Mg cos theta, since they both balance themselves. Okay, that therefore means mu s is just going to be mg sine 30 degrees. All that divided by n. N is mg cos 30. Mg cos 30 degrees. So mg and mg they cancel, and this gives me what? Tan 30 degrees, right? Great. And what is the exact value of tan 30 degrees? My mu s in this case is equal to what is the exact value of tan 30? Great. It is 1 by root 3. 1 by root 3. Yeah, so that's the exact value of tan 30. That's the exact value of tan 30. So that is the value, the approximate value of the coefficient of static friction in this case. Great. You can decide to give it as a decimal, but if it's in maths mechanics, you can allow it like this. But in physics, you can decide to put it as a decimal. Yes, you can put as a decimal and see your answer. Yeah, so thank you, and please subscribe to the channel. Please subscribe to the channel if you've not subscribed. If you're still new, please subscribe to the channel and press the notification icon so that each time videos have been uploaded, that's better videos of good quality than this have been uploaded, you'll be the first person to be notified. Please like the video and see you